Like you said, my name is Jason DeRuyver. I used to work for 18 years at the Michigan Department of Transportation. I've been with HDR for 2 months now. Gave this presentation at our Michigan Bridge Conference. We have an annual Michigan Bridge Conference every year. Gave it in the spring of this year on a product we wanted to try, a product I actually learned about at one of these conferences. I gave the presentation with David Kiefaber from Geotree, so I'll apologize right now. I'm not the technical expert on what a geopolymer is, but he couldn't make it because for some reason OTech decided to have their conference the same week as this, so he's at the Ohio Engineering Conference. So this is David Kiefaber. I've got his number up there on the board. If you have any really technical, nerdy questions about geopolymers, you can write that number down. It'll be on my last slide as well. He is their technical guy for Geotree and these spray-applied geopolymer liners for culverts. So what is a geopolymer? It's not a plastic. It's kind of like a concrete, but it's not a concrete because it's not the same material. But it looks like a concrete and acts like a concrete, but it's not. It's geopolymer. It's got different chemical properties. It's a little more corrosion resistant than concrete, a little more resistant to acids. And typically, if we're going to have corrugated metal pipe in Michigan fail or get a lot of holes in it and section loss, it's because we have really acidic soils around it. So when I learned that this was resistant to acids, I really wanted to give it a try. Here's a real fancy chemical structure that I don't know anything about, other than he told me that concrete and water don't chemically bond. The concrete uses the water, but in a geopolymer they actually chemically bond. There's a comparison chart to Portland cement versus the Geospray geopolymer. You can see here the acid resistance is very good for the Geospray and not as good for the Portland cement. Another thing I'm going to talk about is this can be sprayed in layers and it'll self-adhere amongst the layers, whereas concrete's not as good as that. They can rehabilitate all kinds of pipes, stormwater pipes, sewer manholes. They've done tunnels and bridges, and they have commercial and industrial applications they can do. So a Geospray mortar has a high-performance polypropylene fibers in it, and it's designed for structural rehabilitation. There was a question earlier in the last presentation of, well, how do I inspect it now? And I'll get into this in a little bit. But the requirement for the design of this Geospray mortar is that it's going to be under the assumption that the CMP behind it is 100% disintegrated eventually. So it'll be inspected and rated as if that is the only load-carrying member, because you're not going to actually know if the CMP is behind it anymore. Give a few of the Geospray physical properties. Gets 8,000 psi, compressive strength. Got an initial set time of only 60 minutes, initial cure time of 90 minutes. It doesn't lose any of its strength in freeze-thaw cycles. It doesn't shrink as much as concrete. And it's a little more abrasion resistant, so if you're in a stream situation, it can handle abrasion a little better. They tested its self-bonding by pouring a sample cylinder and leaving a 45-degree angle on the end of the cylinder, letting it set up for a day, and then pouring the remainder of the cylinder along that 45-degree angle. You can see here in the picture that there's a joint in that cylinder, and then they ran it through a compression test. And you can see on the top that in the compression tests of the Geospray mortars, it did not break along the 45-degree angle of the joint, whereas they did the exact same thing for Portland cement-based products, and it did break along that 45-degree joint. Like I said, it's very corrosion resistant. He talks about some microbial-induced corrosion that you could get in a stream situation that can cause some emissions, that can cause CMPs or other culverts to disintegrate, that these geospray mortars can resist. Like I said earlier, they're very acid resistant, so if you have acidic soils or acidic waters, it'll be resistant to that. The design methodology, like I said, they're designing it as that's the structural carrying member, and whatever was behind it is no longer considered as being present. They use I think it's the beam method from the structural mechanics of buried pipes. And they actually went, so they can be applied to any one of these shapes up here. And they went to Louisiana Tech and did some experiments to verify that the beam method was the best method to use from that design manual I showed you. So they spin cast a bunch of pipes, their material, into some sonotubes. And here you can see all of their different pipes that they tried. Most of them are circles, it looks like. Then they loaded them up at Louisiana Tech until they got a crack in the very top, the deload crack. And then they charted it up here, and for their mortars that were 2 inches or greater in thickness, its distributed beam model was their closest result from all the other different models you could use to do the design of these culverts. And they tried it on circular pipes, but the distributed beam model transfers to the arches and the plate arches. So this can be spin cast as well. And I asked them, because the first time I wanted to see this done, a local agency in Michigan wanted to try this product as well, and they were the first ones in Michigan to do it. And I went out there and looked at it, and I was expecting to see a spin cast, and there was a guy in there with a hose, and he's just spraying it on the wall. And I'm like, well, what happened to the spin cast? He's like, well, the only time we spin cast it is when the pipe is too small to get a person in it. Otherwise, we're just going to spray it with a hose manually. So, as mentioned earlier, when you can do in situ repairs and not have to replace the culvert, you're going to end up saving a lot of time and money on top versus the total replacement. So the spin casting process, forms the lining. It's rapidly distributed as it's pulled through, as the sled is pulled through. Sometimes it'll take multiple passes to get to the thickness needed. But like I said, the geopolymer bonds to itself. You can see it looks like there's two different methods. It's air-driven or mechanical-driven spin casting. And like I said, here's an example of the hand spray, which is all I've ever seen. I've not actually been in a culvert project small enough for them to use the spin cast. The advantage of in situ repairs, smaller construction footprint, less disruption to traffic, so it's very desirable to look at this. Geospray approvals for their geopolymer, you can see on the screen here. Approved for field testing versus green is approved. And I will just want to have one note that Michigan does have an Upper Peninsula. There was somebody that committed the cardinal sin, in my opinion, as a Michigander, and they didn't have an Upper Peninsula on their U.S. map. So they must have thought it was part of Canada or something. So, all right, so these are some of the sample jobs they've done with GeoTree. 9-foot diameter CMP, needed a 2-inch lining. They did a 14-foot span plate arch that needed a 5-inch lining. I'm going to go through some of these just to get to the one that I did. They actually did a masonry arch culvert with a 1 3/4 inch lining they put in it. I don't know how many people have masonry culverts out there still. Sounds pretty old. Elliptical pipe culvert they did. So the project I was interested in is I wanted to identify a CMP project where I could try this and it would be easily inspected. So we chose it's a CMP that actually carries traffic. It is the driveway to the federal prison in Milan, Michigan, not Milan, it's Milan. It's a little bit south of Ann Arbor. So it's a 170-foot long plate arch that goes underneath US 23, extremely busy road right there. So we're not going to be doing a full excavation to replace this or putting in a new bridge. So we wanted to look for something in situ. 15-foot span, 13-foot 4 height. Constructed in 1962, so it's already a 60-year-old plate arch. So here's a kind of cross section of it. It's not a very well, it's like the maintenance entrance to the prison. So there's like a gate there, but there's no gate shack and the gate's never closed and anyone can just drive in accidentally. So, but this is what it looks like. There's a close-up view of it. Single lane asphalt road through it, just for maintenance deliveries. And then along the base of the culvert, at the curb line, where they just had some dirt behind the curb, that's probably stayed wet for the last 60 years. There was a lot of deterioration, and the inspector's like, well, I wonder how bad that deterioration is. So he tapped it with a hammer and blew out a hole in the side of the culvert, and lava started coming out of the side. They actually called it the Wendy's Frosty machine out there because that's what it looked like coming out of this hole. And what you can't tell from the previous picture is US 23 looks pretty normal right here, but you're actually just maybe 300 feet away from the freeway is in a sag vertical curve diving down underneath an at-grade railroad. So we're in a giant hole, and the water table is actually almost up to the freeway. So you can actually look at these side slopes and you can see water pouring out of the side slopes any time of the year. And it's always wet. So it might not have rained for a month, but that driveway is still wet. So the dirt behind it is saturated and it's just started leaking out like a smoothie machine here. And so I called it when I was at MDOT, our unofficial request for action process, when the inspector goes, how am I going to fix this? This is ridiculous. And they'd end up calling myself or someone else in my unit and telling me the problem, and we'd have to come up with a way to solve it. And most of the time that was done by this group. That's why I love this group. I can say, well, I know who exactly to call, my industry rep to help me solve this problem, or a different state to help me solve this problem. And that's what this group is for, and that's why I'm here every year. So that's what we did. I reached out to GeoTree and I said, hey, can we get this lined? This is the project I've been looking for. And so we did that. And then I went out and had to develop a special provision because this is a brand new method in Michigan. And that's another thing I lean on this partnership for. I called around, hey, has anyone ever done something like this? Do you have a sample SP I can use to manipulate to Michigan standards? And we got it done. And then I do have a side note. If you're writing an SP and you quote an ASTM standard, please read the ASTM standard. Don't just put an ASTM standard in and say you're done, because it might not actually apply to what you're doing. Or it might not even exist anymore. I've looked at SPs before and I've gone to the ASTM portal and I'm like, well, this doesn't even exist anymore. So we can't use this special provision, because sometimes those ASTMs do get retracted. And part of our special provision, we go through a whole construction sequence for the contractor has to use. You know, we have to obtain a design from the manufacturer, which I had in advance from GeoTree, just so I could get a cost estimate and be able to show it correctly, but they still had to get their own design from GeoTree stamped by a PE. Gave them HS20 live loading. Like I said, we assumed the water table for this culvert was all the way up to the road top, even though this isn't a stream. And all the calculations had to be signed and sealed by a professional engineer. So we also wanted a chemical analysis report to verify that we were getting a geopolymer and not a concrete that we didn't want to try. They had to give us certifications on all their people that had experience. And one thing I will say that is the hardest thing about innovation, at least in Michigan, is we'll do all the right things and innovate and design. It'll get out to construction, and the construction people and the contractor will be like, hey, we have a value engineering to put in regular stuff and we'll save you money, and then the construction office accepts it. But so luckily I was on top of this project the whole time. Wanted to make sure they got exactly what we wanted so we could actually get this trial done. So just keep an eye out for that if you're ever doing an innovation.
Are you saying construction sometimes changes the design?
Yes. Sometimes, and they don't tell us.
And they never talk to us?
No, they don't.
I've never heard of that.
No. It didn't look like a lot of damage along that curb line, but that asphalt had been in there for 60 years, and I'm like, I have no idea what's going on under there. So it was just fingers crossed that they could still do a culvert lining and they wouldn't take this asphalt out and find it was totally disintegrated, because then that's a whole different project. But they took it out, they got it cleaned, and you can see that it doesn't look too bad. It was just all along that mud line. Here's some of the spray lining being applied inside the culvert. And you can see it's not a stream, but there's just water always running through this thing. So they had to do some mitigation for that as well, just because it's below the groundwater table. And then we were going back with a concrete pavement that we'd never have to hopefully touch again, because all they have is delivery trucks going in and out of this instead of asphalt. So we put in a liner separator because we didn't want our concrete road to be adhering to the pipe liner that we put in. And here's the finished product. And we took the curb all the way out to the edge, so there's not that dirt pile up that they just had dirt there on the edges before. Lessons that we learned, you know, you can't write the perfect special provision the first time, so luckily I was on the phone with the construction engineer every day, making sure they understood everything. And the lessons we learned was, you know, it was easy to overlook things. You know, it's easy when you write a special provision and you see something that's wrong, but it's very difficult to see something that you missed. So like I missed, like, how frequent does the office need to test the material coming out? What kind of test do they need to do? How often do they need to sample it to verify during construction? All this stuff is clearly defined if it's a concrete, but not a geopolymer in our state. We also didn't address, you know, the what-if defects that we could have had, like, was there honeycombing in the spray applied process? You know, what kind of cracks did this process develop? So that all had to be done on the fly during construction. So if you are doing something innovative, make sure you stay involved through construction to learn how to make your SP better for the next time and to help them as they're going through those problems. Set clear expectations with the manufacturer beforehand. Sorry to the industry people in here, but sometimes you oversell your product. And I was expecting something, you know, to perform differently than what it actually did in the field. It still performed satisfactorily to me, but, you know, they sold it like way up here and I got here, you know, so there was this gap where him and I butted heads a lot. So, but we could have avoided that by just setting clear expectations ahead of time. Like there was some cracking that developed, and there was some infiltration of water coming through the cracks because, like I said, it was below the water table. So we didn't have any. He was trying to sell me something that it was never going to crack, but it did crack, and so we had to work through some of that. And then something else that we missed in the SP is it was a very rough finish, just spray applied. And if there's going to be any prison employees walking through there, they wouldn't want to bump up against it. So if we ever did this again in a pedestrian situation, we would give it a broom finish to be a little smoother and a little more gentler on skin. And that's it. Like I said, if you got some questions about the real nerdy geopolymer stuff, give David Kiefaber a call, but I can answer questions about the actual project itself.
Is it technically considered a tunnel now? It looked like a tunnel to me. You don't have to answer that.
That's right.
How did you stem the flow of the Frosty?
Well, we have an emergency process in the state, and we got them to pack some grout in it, some fast set grout.
So just pumped grout in and held it until it cured?
Yeah.
Okay, nice.
There are each one of our regions has their own bridge crew, and they came out and they put in fast set grout until it stopped.
Hi. Did you have to address the rust? You know, the rust that you had, did you have to address that, or would you expect if the rust progresses, would it delaminate or not?
Nope. Because the design assumption was 100% section loss of the entire pipe, and the only structural component left was the geopolymer. So we didn't address anything.
So would it delaminate, you think, at all, or not?
It doesn't need to bond to the CMP behind it because we're assuming 100% loss. Yeah, they have to give us calculations that they are the structural component.
Hey, so sorry, I meant to ask this as well. What if you have deformation of the top of your pipe to where technically that's going to go into tension due to live load over the top or something like that? Can you still use the geopolymer? Does it have tension capability?
I would say that if you've got pipe deformation, you're beyond in and sit.
Okay.
That's just my opinion.
Yeah, that was.
If your pipe's collapsing, that's a different repair.
Okay.
That's my opinion. Maybe there is something out there that I just wouldn't trust it personally.
I have a quick question. Does the hydraulic, is there a hydraulic issue? Does this flow full, and then then the finish being rough, is that?
It'll increase velocities. So, I guess it just depends. For me, it's a maintenance repair, so I don't involve our hydraulics unit in maintenance repairs.
I used to do hydraulics, so, but that's why I was curious whether you were concerned about hydraulics at all.
Not in this one, but obviously if it was a stream crossing, we'd have to consult them, possibly.
Any other questions? Nope. Thanks, Jason.
Thank you, Jason.